Ladies and gentlemen, welcome to the Vint Cerf hangout at BET 2012. Dana's saying wait. Yep, I'm ready to go. I'd like to introduce everyone here to Vint Cerf. He's Google's chief Internet Evangelist. And for those of you who don't know, he's often recognized as one of the fathers of the Internet for co-inventing the architecture and basic protocols of the Internet. He's received for that the U.S. National Medal of Technology, the AMCM Turing Prize, the U.S. Presidential Medal of Freedom, and the Japan Prize. Today, Vint is going to talk to us about the future of the Internet and how it relates to education. So, handing it over to Vint.
Thanks very much, Dana. Hello, everybody. I'm glad that we aren't trying to introduce everyone by name. That would take the rest of the day, although I would love to have the opportunity to join you face-to-face, and I hope sometime I'll have an opportunity to do that. So just to confirm, am I audible and am I understandable? Can somebody wave and say yes? Okay, yes. Thank you, Dana. Now, whether I have anything good to say, that's for you to decide. First observation I would make is that we're seeing a remarkable transformation in the way in which we generate and share and find information with this rapid spread of the Internet. Everyone in the room is well aware of that. You all make use of mobiles, that many of which now are capable of getting access to the Internet at need, no matter where you are. And that trend will absolutely continue. And in fact, this year especially, there's a major transformation happening in the Internet. Some of you will know that the original design of the Internet had room for only 4.3 billion terminations. Way, way back in 1973. Bob Kahn and I were doing the design and trying to figure out how we could make this experiment work. And we thought, for an experiment, that 4.3 billion endpoints ought to be more than enough. Of course, here it is some 30 years later, and it's very clear that we're going to need more address space. We literally ran out of the allocations of the 32-bit IP version 4 address space in February of last year. So the Internet Corporation for Assigned Names and Numbers is now allocating IP version 6 addresses, and in June of this year, I hope that we will be able to turn on IPv6 at least for test purposes, which we did last year in June in 2011. We'll do it again in 2012 in order to verify that we can get both v4 and v6 running in parallel at the same time, and that way literally trillions of devices can be supported on the net. But the thing I wanted to focus on especially is the trends that we're starting to see in terms of educational use of the Internet. One of the more dramatic examples of this was when MIT announced it was putting all of its content, all of the coursework, courseware, up on the Internet free of charge. Anyone can get access to it. Some people said, "You must be crazy." And I thought the response was rather interesting. They said, well, let us explain to you what we have in mind. If you go to the MIT site and you look at the coursework and you already understand it, then you don't have to come to MIT. On the other hand, if you don't understand it, the only place you're going to learn how to understand it is to come to MIT. So I think their intent is to help people gain an appreciation for the scope and depth of education available at that institution. But at the same time, that course material allows others, tutors and people at other universities, to flywheel off of that content and to make it even more useful and more widely accessible. Speaking of things being widely accessible, I hope all of you appreciate that Google's primary purpose in life is to make the world's information more organized and accessible and useful. And we hope that education will be one of the many beneficiaries of that particular intent. So today we're also seeing a great deal of opportunity for collaboration in addition to simply sharing of information. One thing you're seeing with Hangouts is a way in which multiple parties can be interacting with each other concurrently. I've spent the last year or two using Google Docs and Google Talk and Google Video as a way of coordinating and collaborating in the production of documents, whether it's just text or maybe it's a presentation or maybe it's a spreadsheet that we're all working on. The fact that you can all interact with it at the same time, see what the other people are doing, creates a collaborative environment that lets you get things done very, very quickly, compared with sending draft copies around as attachments of email, then nobody quite knows what the most recent version is. So this notion of being able to work together in real time on commonly accessible objects is very important. A related topic is the sharing of large-scale databases. Some of you, I'm sure, are well aware of the scale of astronomical databases. The scale of the output from the Large Hadron Collider, for example, is measured in terabytes to petabytes. The ability to store that information and make it accessible and, let's say, manipulable is very important. Some of you will remember that when the Human Genome Project was at its peak, when people were rushing to try to identify the genetic sequences of the human genome, there was a requirement in the publications universe, Nature magazine, Cell magazine, and Science magazine, that if you published anything about your a DNA sequence that you had identified, if you wanted to publish a paper, you had to put the DNA sequence and the metadata associated with it in one of the 3 human genome databases, so it would be accessible to other researchers. This is a really important observation, because the consequence of that rule by those 3 publications meant that if you were doing research and you found a particular sequence and you wondered what is known about that sequence, you could then go to the Human Genome Database and look it up, not only find out what was known about that sequence, but find out who else was working on it. This has created unexpected collaborations when people discovered that they had common interests that they didn't know about ahead of time. So this kind of acceleration of the scientific process and the ability to discover information, whether it's for research or education or, frankly, for business, is one of the features that this gigantic network introduces into practice. So this is the kind of thing that I'm anticipating happening in the educational world. People will create content that other people can share. Every one of you that has a mobile phone, especially a smartphone, will know how rapidly the collection of applications has grown for the iPhones, for the Android-enabled phones, and others. The reason that that has taken off so quickly is that a standard, an application programming interface, has been established to make it easier for someone who invents an application to get it into use, to make it accessible, make it downloadable. This notion of creating platforms and creating standards that allow other people's content to be purposed and repurposed is one of the key essences of the internet today. When you look at the applications that people have made of Google Earth and Google Maps, which provide a standard interface for presenting geographically indexed information, you can appreciate how this kind of platform leverages other people's information and allows them and others to make use of it. So those are the kinds of things that I believe will influence the way in which the internet is used in education. But I'd like to stop this peroration and see whether you have some ideas and some questions that you'd like to discuss. And I'll ask Dana if she could please orchestrate that for me.
Vint, can you hear me?
Yes, I can.
Okay, great. Does anyone have any questions they'd like to ask Vint Cerf?
Could I suggest that it's not just the questions? That makes it sound like I have all the answers. I think people that I'm looking at right now on the screen have the answers. Let's have a discussion.
Okay. I'm going to throw the mic randomly to this poor gentleman on my left. No? Well, Vint, I'm going to trigger off with a discussion question then, to kind of warm up the audience here a little bit. When you were designing the original architecture for the internet, you had ideas of how you thought it would be implemented. What do you think is the next quantum leap for the internet? What's going to be the next stage out there for the internet as we know it today?
Well, there are several things that we can see already. First of all, mobility and mobile access is obvious. Second, sensor networks are becoming an increasingly common part of the internet. So we're going to find homes and offices and vehicles and appliances and everything else part of the internet environment. The smart grid program in the United States and comparable ones around the world are beginning to adopt standards that allow appliances to be part of the electrical grid and part of the information grid, which the internet represents. So that's another trend that we're going to see. Another thing which is happening in our world at Google is the introduction of artificial intelligence, not only in the search engines, but in translation. In fact, just this morning, I received an email that was commenting on an op-ed that I wrote for the New York Times not too many days ago called "The Internet is Not a Human Right." It's generated enormous amounts of debate and discussion, not all of it in English. Now, my Russian is "Я говорю медленно и плохо по-русски." So I turned to Google Translate to get some help. And it translated the Russian article for me so I could see what the responses were. We're doing better and better here at Google in doing these translations. We deal with up to 50 different languages. Imagine if we could do much better so that not only could you translate written material, but you could translate material in real time. That is, do speech recognition, language translation, and speech synthesis to translate into another language. That it would accelerate our ability to collaborate and work together. So we think that that kind of artificial intelligence is important. Some of you will know that we have automobiles that drive themselves at Google. They've driven 200,000 miles in San Francisco. Now, we don't let them go off by themselves. There's always a human being in there just in case, but they're not driving the car. The cars actually figure out where to go, how to turn, how to stop at traffic signals, how to not run over pedestrians, how to not stop waiting for a tree to move that isn't going to move, things like that. So there's quite a bit of intelligence that has gone into making these cars function. There are some people who believe that the world will be safer if the cars drive and the people don't, because the cars don't get upset, they don't get in a hurry, they don't have vindictive reactions to anything. They just drive, and moreover, the cars could be talking to each other about what they're planning to do, so that they can coordinate actions and make it safer for all of us. So the world will be safer if we stop driving cars and let the cars do that on their own. So those are the kinds of things that are going to be emerging out of the internet environment, and I haven't even touched on the plans for the interstellar expansion of the internet. We've already got an interplanetary internet underway. Now there's a project going on to go to the nearest star and bring communications there as well.
Thanks, Vince. Do we have any other questions from the audience? Sorry, I have one here.
Hi, Vint. What advice?
Hi there.
What advice would you give to a school as such, education establishment that's looking to upgrade their information technology as such, bring it forward to the relevant?
Yes, good question. And in fact, that question has been asked of me by a school here in Northern Virginia called the Thomas Jefferson High School for Science and Technology. They're just in the middle of a major upgrade, a $200 million upgrade of the school campus. And the question was, what kind of information technology investment should they make? And the answer turned out to be, don't buy a whole lot of computing equipment and invest in that and put it in the school. Instead, invest in high-speed access to the internet, 100 megabit access if possible, or gigabit access, even better, and make use of cloud computing as the primary engine for doing computing, for letting kids try out new software and experiment and so on. The reason that that turns out to be important is that instead of investing in a piece of hardware which will simply get stale at a fairly rapid pace, instead you invest in the infrastructure that gives you access to computers that are going to be upgraded in the normal course of events. So this is not just getting to the Google cloud, but getting to the Amazon cloud and getting to the Microsoft cloud and getting to the IBM clouds and so on. So that was our advice. Clearly you need end devices, you need terminals and things like that, and maybe some computing resources for doing experimental work, for example, in network security. But for the most part, for serious computation, for dealing with large-scale databases, for allowing a lot of collaboration, access to a cloud-based resource is by far the best strategy for the rest of this decade.
Great. Thank you very much, Vince. I'm going to close now because I think we've taken up a huge chunk of your time and everyone here. But thank you for your time, and hello from Beth.
Okay, it's a pleasure. All right, take care, everybody. Good luck.
Thank you.
Bye for now.
Bye.